Welcome to the AI Checkpoints. Just a quick heads up before we dive in. This content is generated by AI using the sources you provided. Today, we're looking at something pretty big from Hugging Face. It's called FinePDFs. It's this massive new dataset they've released, and it really could be a game changer for training large language models. We'll get into why it's such a big deal, the sheer scale of it, and how they tackled the tricky problem of getting info out of PDFs. It's like opening up a whole new frontier for AI. So we know LLMs need tons of data, right? But
Yeah.
the thing is, the AI world is kind of hitting a wall. They're running out of easy-to-grab web pages for training data. It feels like the low-hanging fruit is gone.
That's exactly the problem they're facing. And what's really interesting here, the solution was kind of staring us in the face all along. PDFs, billions of them. But, for a long time, people avoided them. The Hugging Face team themselves mentioned the incredible extraction cost and complexity. It was just too hard, too expensive. But FinePDFs goes right at that problem.
Right. Turning this, data graveyard into a gold mine. And the scale we're talking about, it's not small. Hugging Face says it's the biggest public data set just from PDFs. Get this. Around 3 trillion tokens.
Yeah.
That's across 475 million documents. And wait for it, 1,733 languages.
Wow, yeah, 1733. That's staggering. Almost every major language, really. All that knowledge locked away, now potentially usable for AI.
And it's not just more data, it actually improves performance, right? They found mixing FinePDFs with regular web data gives a significant performance boost. They're getting results almost as good as top-tier collections like the Small M3 web mixture. That's huge.
Absolutely. It's not just volume, it's accessing specialized knowledge that wasn't easily reachable before. So where did it all come from? They pulled from 105 Common Crawl snapshots. For anyone listening, Common Crawl is like this massive web archive going way back. These snapshots cover summer 2013 up to early 2025.
Okay, so a huge historical sweep of the web's PDFs.
Exactly. Then they refetched them and processed everything using their own tool, Datatrove. It's their toolkit for handling these enormous raw data sets. The end result, about 3.65 terabytes of cleaned up data.
3.5 terabytes, just PDFs. Okay, so collecting it is one thing, but the extraction, that's the kicker, isn't it? PDFs can be such a nightmare. You've got simple text ones, but then scanned images.
Right. The complexity is why their approach is so smart. They used a two-tiered system. For the straightforward digital PDFs, where the text is actually text, they use a, quote, cheap text-based method, runs on normal CPUs. But for the scanned ones, the image-based ones, that needs more power. So they use a more expensive image-based method, that's OCR, optical character recognition. They use RomaCR running on GPUs for that.
Okay, so 2 paths. But how does it know which path to send a PDF to?
Clever part. They trained an XGBoost model. Think of it like a traffic controller. It looks at the PDF and quickly decides, is this easy text or does it need the heavy-duty OCR treatment? It's pretty efficient.
That is smart. It saves a lot of unnecessary processing, I bet. What about other PDF quirks, like documents with multiple languages? Manuals often have that.
Yeah, they call that code switching. It's common in PDFs, less so on web pages. So they added a filter. Basically, a document is kept only if more than half its pages are in the language you're actually interested in. It helps keep the data relevant for specific language modeling tasks.
Makes sense. And cleaning. You can't just dump raw text into a model.
No way. Data cleaning is critical. They did the standard stuff, like deduplication, removing exact copies and near duplicates using minhash. But crucially, they also focused on PII anonymization. Personally identifiable information. They specifically targeted emails and public IP addresses to mask them.
That's really important. Privacy is a huge concern.
Definitely. And they even state, for transparency, that there's an opt-out form. So if you somehow find your personal info in there, you can request removal.
Good to know. So we have this massive, clean, diverse data set. How does using these kinds of documents, especially longer ones, actually help the AI models?
Well, a big advantage is long context understanding. The average FinePDFs document is almost twice as long as docs and other common data sets. Many are over 100,000 characters. Training on this helps LLMs get much better at handling long reports, scientific papers, legal texts, stuff that needs sustained comprehension.
So better focus on complex, detailed information.
Exactly. And think about the social impact. This whole process is transparent. It lowers the cost for others building models. And, crucially, it unlocks knowledge in specialized fields, science, law, engineering, that was mostly trapped in PDFs before. It's like opening library doors.
Are there any downsides? Biases, maybe?
They do acknowledge potential biases. The data comes from the web ultimately, so it inherits web biases. And maybe some bias from the LNs used in extraction, although they didn't apply NSFW filters specifically, given the nature of many PDFs like academic papers. It's something users need to be aware of.
Right, always a consideration with large data sets. So wrapping up, what does this all mean for you listening? FinePDFs is this huge effort to unlock knowledge. It paves the way for LLMs to get smarter, especially with complex, specialized information. It's a really big step.
It really is. Just imagine what becomes possible when AI can properly understand all the detailed knowledge that's been locked away in PDFs for decades. What new connections, what insights might bubble up from all that hidden wisdom? It's quite something to think about.
Definitely something to mull over. Hit like and subscribe if you like the content. See you next time.